the level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
is it an old level? The old one with the old Brian Mullen force line, because I've never really looked over that either.
Oh, Brian Mullins?
I think it's linked. He did force the line, didn't he?
The only thing that's going to end this is a force the line test.
Yeah, he proposed it. I thought I saw something like a year ago where he wanted to build some big steel rail contraption, but I don't know. We've got the Lygos vacuum tubes. That's a pretty good construction of a straight line tangent at the intersection and climbing about 1 meter and something in elevation to maintain straight. So there's that.
I think we lost him. Right there.
Larry.
Mm-hmm.
Oh, is he gone?
Did he leave without saying bye?
He may have dropped out. Maybe he'll come back.
Yeah. I wanted to have a word with him about our water level test, the straight line test.
Mm-hmm.
Got into that, but yeah, I was good of him coming round.
Yeah, great. That was I don't know how long that was. Maybe an hour? Not really.
I wanted to know if he had gone back to his building.
Yeah, I wanted to get there. There's loads of questions about Larry.
Well, he's
Crap,
supposed
he may
to,
have.
you know, when it warms up, he was supposed to go back and shoot it again. And I want him to go in the middle and shoot either way, you know.
He may have left because he could sense that was coming. I don't know.
Yeah, I don't know. I hate to put that in him, but he usually doesn't leave. But usually people say, you know, bye when they're leaving. So maybe he just dropped out. Maybe he's not being, you know, a jerk.
No, he's
just
fine.
got disconnected.
Yeah. He just got disconnected.
Yeah. No, I think he'll have lost his signal or something. The power will have gone around at his house. He wouldn't have just dropped out like that.
You still there, Bev?
Yeah.
Oh.
Yeah. Are we on?
Yeah. Mm-hmm.
Wait. So if we get this the test. I mean, what's your idea of what they were doing with the force line? What was that about? What, you know, I never understood what they were doing. They were just building a structure level, were they? Is that what forced the line?
Well, what Brian Mullins described, I don't know. I hadn't seen that since well over a year ago or something, and he had brainstormed something where they could build with at no minor expense, you know, with I-beams and stuff, try to build something of significant length, like a mile or something, and go and in his structure, he wanted to, you know, build something at constant elevation and something was tangent to see if you could or if it would be evident. And
he wanted to build something that was tangent as well as level. I mean, what's that?
Well,
tangent to...
Because, yeah, in his structure, he described building both because they're not the same.
So he's building two structures in the force line.
Well, okay, I don't recall the details of that much because Brian Mullins was being, you know, his typical crazy. So, yeah, he was describing something that was overtly expensive, unnecessary. And, yeah, he was going to, like, I don't know, put a line of steel columns and then across the steel columns, you know, lay I-beams, you know, going out horizontal and going out level. So yeah, he said, well, if you could do both, let's just build it and see if you can do both, and then survey them up and measure them and check them all out. And it was ridiculously expensive. And so what?
So they had I think I heard when they were saying something about it the other day, either 16 or 160. I don't know, 1,600. It's 1,600 meters for a mile, isn't it?
Something like that.
And have you ever seen Slice Barkane's bending water level experiment? Because that was 16 meant to be when he does it, not the leaky one, the new one. That's meant to be 16 100 meter water levels. Would they be like your verticals? Or would you class that as being the level or the horizontal that Slice Barkane was doing?
I don't know what the exact details of his quote new test, where he's going to set the vertical water columns on top of the levee. I mean,
yeah, he's just doing 16 individual 100 meters and putting them, where the water levels of at one ends, he's matching the water level of the start of the next 100 meter, and then he's going with that, right? He's marrying up 16 100 meter water levels.
Yeah, because when he did that first time, he just made such a rookie blunder, as he didn't check the elevation on his first site, and it climbed up several feet, and he didn't realize that until he got out there with his water levels and found, oh my God, the far end is higher than I thought, because he didn't do a proper survey.
How low was it?
I know, and he was counseled to say, you get out there and survey it up, and he goes, oh, it looks level. Well, it wasn't, because the water level proved it wasn't. It just looked level.
Right. Oh, well, I heard that it was just leaking all over the place, and he couldn't find leaks. Is that what he said? He didn't say he had elevation.
He had both problems. It was leaky.
I think that was one of the resulting leaks that we had found when we walked the entire line, trying to find out why filling up post zero kept on going down. And we wanted to find out why that was, and this seems to have been one of those. But we had actually, I had actually taped that all up, and that tape is outstanding, by the way. So now you're going to see this one, and put it down at level. Now this one is back at 11. Now remember, post 1 was 11.5. Post 2, for some reason, was 8.5. Okay, but this one's back at 11.
But he also ran into where at the far end it was too high. He had both trouble.
It was too high.
The far end, yes, appeared to be too high, and it was leaky. Yeah, he had trouble, and I think he should have put a little more effort into the site selection and surveyed it up proper.
The water level was too high, or the land was too high?
The land was too high at the far end. Yeah, it climbed up. The land was climbing up a small amount, which he didn't perceive by a visual inspection and would have learned if he'd done a proper inspection.
He's got an auto level this time, though, hasn't he? He'll be right. I don't know whether he got measuring staff. Do you know if he got a measuring staff with it? Or he just got the auto level?
I don't know what he has. I only catch him a couple of times he puts out a video. I'm not tracking his experiment outline or his I got an idea of he was going to go up to the top of the levee, because that is a constant elevation, unlike where he was on the bike trail.
Yeah. Yeah, that sort of makes sense doing it at the towpath at the side of the canal. That makes sense. But I mean, what I was trying to get at is that 100-meter individual things. Would that not be like a force in the line sort of thing? Is that not what Slice-Bark-Ames is doing?
No, because anytime I hear the term force the line, it has so many convoluted approaches to what the force the line is even trying to be, or what it means, or how they're doing it.
Okay. Well, Slice-Bark-Ames called it his a bending water level experiment. Do you think that's what had happened? Would it show a bend?
Well, it would show the constant elevation, and the fact that the constant elevation and a tangent from one end are different. Yeah.
Tangent. It's an even elevation, an even altitude. Sorry, can't get them mixed up, can we?
Elevation. A constant elevation. Yeah.
Yeah, an even altitude though with the water level, because it's not. It's above the ground, isn't it? That's an even altitude rather than an even elevation. If you're using a water level, the tool.
Okay, the elevation of the tops of the water columns.
That would be altitude, wouldn't it?
Okay. Yeah, 3 feet of altitude above the levee. I didn't look.
Couldn't be a tangent, could it, Larry? If it's at an altitude above, it can't be a tangent then, surely. Geometric.
I said from one end, you would have the tangent, and you would have the constant elevation.
Altitude, though. Yeah, if it's an altitude, how is it a tangent? Tangent needs to be touching something, and if it's at an altitude, what's it touching? It's just in the air. You can't have a tangent touching air, can you? I mean, that's ridiculous. That's presupposing air curves. You don't do that, do you?
Well, I mean, if you're going to make a silly description like that, sure, why not?
What you think?
Because if you set up a water level, and then you set up an auto level, and the water level as it progresses out a mile will be at the constant elevation, and the auto level at one end will be looking out tangent, and you see the two will be separating as distance goes by. Just like on the LIGO vacuum tube.
The water level drops, do you?
No, it's a constant elevation. It's a constant elevation, so it's going to be the 3969 mile radius of the planet, and an auto level set up at one end will be tangent to that curve, even if it doesn't touch it. A tangent is a concept, all right?
What? No. A tangent is a straight line that touches a curve at one point only. It's a mathematical description.
Yeah, at one point only. I said at the beginning.
Yeah, but if it's at an even altitude, it's not touching anything. It's in the air.
Yeah. See, when you make a funny comment like that, then I know you're not serious.
Yeah, but it's not a funny comment. You understand what hydrostatic equilibrium is, right, Larry?
Yeah.
Right. At an even altitude of even pressure across the water surface, the ends of the water level, it would create a horizontal line.
Well,
right?
Make a constant elevation. And
no drop, no tilt, no slope, no grade, just an even altitude. With one end neither being higher nor lower than the other. Yeah. That's my thingy gone. Still here.
Yeah, we're here.
Sweet.
Probably just thinking.
Yeah, it's the law of hydrostatic equilibrium. At an even pressure, the ends of the water level can establish a horizontal plane of reference. That would be a dead straight line.
Yeah, we're trying to do the force line thing, is Slice Sparkane doing his version of a force line? Is that what Sly's doing? I mean,
I refer
that's
to the graphic. I refer to the graphic I just put up in the chat.
Oh, let's have a look. In live chat.
So air does curve.
Oh, that graphic. Where did you get that from, Larry?
The Royal Engineers.
Wow.
Your buddies, the Royal Engineers, finest mappers and geodesists the planet has ever known.
Wow, so that you've got a horizontal line being a tangent there. Is that where everybody keeps saying that all tangents are horizontal? Is that why people get confused when they draw a circle and then draw a straight line there?
Yeah, just notice where they say the labeling of the arcs are the level, the constant elevation. Vertical is a radial to that arc, and horizontal is a definition of 90 degrees to vertical at a point.
Level isn't a circle, though, is it? You can't. You can't have parallel planes if it's a circle.
I defer to the Royal Engineers because that matches my measurement and observations in that graphic.
Measurement. What did you measure? Sorry. What we're trying to get at here is they're doing a force line. Now, Slice Sparkane has got 16 100-meter water levels. Now, are they a straight line thing? Are they measuring a straight line, or is he going to be measuring the level line? And what's he going to be referencing his level line with an auto level? Like, does that level, the auto level, like, is that, I mean, what are they referencing one from the other in your surveying experience?
The tops of his water columns will all be at the same elevation.
I gotta ask you. Yeah, I gotta ask you one quick question though. So, are you saying that the curvature rate of air is altitude dependent? I know that sounds crazy, but that's what you guys are talking about.
I didn't make any reference to air. I don't know what the hell that matters.
Well, it does. It gets away with you. There's no such thing as parallel. You don't have the concept of parallel in that geometry that you're talking about with ridiculous bending level lines, right?
It's concentric to the center of the Earth. Yeah.
Not parallel, right? So when they say, everyone says that horizontal is parallel to the plane of the horizon, and as you know, surveying, especially elevation checks and all of that, is based solely on horizontals being parallel, right? Well, that isn't a curve, right? That isn't what they do. They measure a drop in the vertical, don't they? When you're doing surveying on your measuring rods.
Yeah, you do. And that's
if it's a change in the vertical, then what do you call that when you're measuring, when you're doing your surveying?
Change in elevation.
Right, okay.
And that's why there is procedure to using an auto level and rods to, when you make the reading to the back rod at, say, 200 feet, you must make the reading to the forward rod at the same 200 feet. Mm-hmm. It has to be symmetrical at all times, so that the curvature behind the curvature above you, in front of you, is the same quantity. And then you pick the instrument up and you move ahead, and you do the same thing, maintaining symmetry. Always maintaining a symmetry.
Larry, have you ever done a 2-peg test?
Yeah, in my 40 years of surveying, I have calibrated many a level. Yeah.
Right, okay. Well, you don't do that with even, do you?
But you also do it over very short distances.
But that's what, like you just said, you have to do it with even. Well, you don't when you're doing a 2-peg test to check whether your tool is in alignment. You offset it, don't you? You have one really close and then one far away. That's how you do it, right? To prove it's a plane and there's no deviation over distance.
Except you keep the
That's what a
distance.
2-peg test is.
Yeah, and you do a 2-peg test over like 100 feet.
Yeah.
You
I got
don't do it
one.
over-
How far?
I got
do
one
you
question I want to ask.
get level?
Sorry, Bev.
How far do you use your auto level, Larry? How far?
Depending on the precision I'm going for.
Yeah.
Yeah, like a couple hundred feet tops.
Okay. So if you use a offset it in order to keep it horizontal on a horizontal plane over small distances, and you only use it over those small distances, then are you not establishing a horizontal plane? Always.
Yeah, because in short distances, with curvature being very small in short distances, and again, it depends on the precision we're going for and the size
No
of the project
curvature
area.
for horizontal though at all, is there? It's a straight line.
Yeah, you're right. No, you're right. The Royal Engineers are wrong. So I feel to you because all of
Just
geodesy.
talking about straight lines, Larry. Don't get upset.
Hey, Bev, can you hear me?
Yeah.
I just wanted to ask you one quick question, Larry. If you survey out 1 mile, right, using your auto level, doing differential leveling, and you measure an 8-inch drop, would you call that an elevation change, or would you call that earth curvature?
Doing proper differential levels of the course of a mile, there could be elevation change, and the procedure in using differential levels would preclude finding any 8-inch curvature change or change in curvature because I'm over a piece of irregular terrain. Doing proper elevation change measurements with differential levels over the course of a mile, moving the instrument incrementally along that mile, and had, say, along a railroad track or something where there is perhaps no elevation change, and you measure the vertical angle across that, you will get, in fact, the same elevation after you account for the 8 inches of curve. Yeah.
So using the auto level across a mile and you measure an 8-inch drop, just simply, is it an elevation change or is it earth curvature?
If I use the level and observe that entire mile in one observation, yeah, I would. that elevation 8-inch.
Mm-hmm. Go ahead. Sorry. Go ahead. I'm sorry. Are you there?
If you set an auto level up, and you observe a mile in one shot, to get the elevation at the far end is not just reading the rod, it's reading the rod and accounting for the fact that we're on planet Earth.
Okay, now what do you call that technique where you look out a mile beyond the instrument's limitations? Would you call that reciprocal leveling at a distance of a mile?
If I were looking at if I were confronted with having to determine an elevation 1 mile distant, I would not use my auto level. I would pull out a theodolite.
So
and
what
I would
do you
measure
call that technique? What do you call that surveying technique where you look out over great distances with a theodolite?
For elevation, it's called trigonometric leveling.
Trigonometric. Horizontal distance, you mean? Not elevation.
There's distance and there's elevation. They're both.
So
yeah.
You would
You
never
gotta
get an accurate reading, right? I mean, you're the professional. You would never get an accurate elevation change looking out across a mile, right?
Using a theodolite at a mile for an elevation determination with the theodolite, it's not hard to maintain a fairly high precision.
You wouldn't do that, Larry. Come on.
One last thing. Do you think you'd be more accurate using differential leveling techniques across that mile, or taking one shot that's way beyond even reciprocal leveling and trying to determine elevation?
It depends on what I'm confronted with. If I have to cross a ravine or if I have to run down a railroad track, yeah, I would use the most appropriate tool for the conditions met. So, yeah, if I have to cross a ravine or if I have to, determine the height of a radio antenna for navigation obstruction clearance, yeah, I'm going to use what tool returns the best option. I mean,
that makes no sense to me. If you have a radio antenna that's built on an established elevation and you know the height, why would you need to sight it from a distance?
Because maybe somebody doesn't know the height, or they want that height confirmed, or it's brand new construction.
Can you tell me? I know you're the professional. I'm just asking you. Can you tell me the limitations of reciprocal leveling across a ravine? And is it accurate? You got to look back. You got to do it 6 times. You got to try to make a average. So you're building a bridge, and you want to kind of be near the other side, kind of close. As you work towards the middle, as you construct it, you know where you're at, right? It's not an accurate determination of elevation.
Yeah, there are procedures. There are methods.
You know the limitation of that? Can I look 300 feet? Can I look 500 yards? How far can you do reciprocal leveling?
Reciprocal leveling for high precision, you keep the rod lengths, the distances to the rod readings to about 60 meters.
So that's not very far.
Right.
Reciprocal leveling is 60 meters.
Yeah. 60 meters behind you, 60 meters in front of you, 120 meters per measurement pair, and then you do that hundreds or thousands of times, or whatever it takes to get to your point of destination, and it's very expensive if you're maintaining the highest level of precision.
Yeah, so you're the professional surveyor. I'm just asking real quick. Do you know the difference between differential leveling and reciprocal leveling?
Well, there's reciprocal leveling in differential leveling, and there's reciprocal leveling in trigonometric leveling. There's an example I just put up there. That's observing that radio tower from a tiny little 1 mile away. And yeah, at that distance with vertical angles, yeah, it can easily be within a couple of inches. But if I were using differential levels, I can't get to the top of that tower. So
that tower was constructed on a known elevation, and the tower height is a known elevation. But you need to look at it.
And how did it get to be known?
Because it was surveyed.
Clearly your mic's going a bit garbled for me.
Okay. All right, sorry. Go ahead, I'll be back.
Okay. Larry, can I just get a check with you? Reciprocal. You know what that means, right?
Yeah.
Two observations.
Yeah.
So where's your shot from the tower?
You're right. In that case, that can't be done. So
it's not
you observe that.
Then you're just observing the tower. You're just measuring an angle.
Yeah.
Of the tower.
So
that's not reciprocal, Larry.
Right. It's not. You're right. That's a different integrity of precision. You're right. That's going to have an uncertainty of some number of inches, as opposed to making a proper reciprocal.
No, you're just making an angle measurement, aren't you? That's all you're doing. An angle from horizontal. Yeah, you are setting it at a 0, and then you're measuring an angle, right?
Yeah, but that I'm measuring it from the gravity vector. I'm measuring it from the plumb line, not from horizontal.
An angle, aren't you?
and distance.
How do you measure a distance?
It's called triangulation. It's one of those math sciences that you're not familiar with.
Well, just tell us then.
In this example,
How do you measure the distance, please, Larry?
intersection of horizontal angles and calculation.
Well, what distance, Larry? Where's your measurement of a distance? You've only got the theodolite, haven't you?
Yeah, the graphic just posted. This is how I get the distance, that is by intersection of all those red lines and knowing the coordinates of the observation point. And the distance is calculated.
Oh, so it's not measured then. You measure angles with your theodolite. And then where do you get your distance from then? Because you've got to, in order for you to calculate a distance, you do need a baseline measurement, don't you? You need an initial.
Yeah.
So where's that come from? Where's that initial measurement come from?
The coordinates of the point of observation.
Oh, from the map.
The coordinates of the point of observation need to be determined to a fairly high precision. Yeah.
From
And the elevation. Well, I don't go to the map to get the coordinates. I use a higher order of precision. You know, you can't just like, yeah, you don't scale them. You don't scale
the maps are first order, aren't they? Surely, because the scale maps are first order. That's already been established. So are you claiming to do a higher order than first order?
Scaling off a map is not first order. It's like no order. It's scaling off a map. It's an analog approximation.
I'm saying the maps and the dimensions and the positions and the points and everything that are already on the maps, they've already been established as first order, haven't they?
Yeah, and the map is made, but the map is made from a series of fiducial points that are first order, and the overall graphic of the map is subordinate to those control points. So I go back to the control points. I use the control points that made the map. I don't use the map. I use the same control points that made the map.
Wow. I mean, the cartographer makes the map, but I mean, it's a scale map. The the distances are already there. They're already known. So you're saying you're claiming to be a higher order than the first order that's already established the maps. So do you get people to correct their maps because you've done something of a higher order?
I'm using the control that made the map. So we are coincident. And if the map is 1 to 25,000 or 1 to 100,000, then yeah, the map cannot, a 1 to 100,000 scale map, if you scale the map, you're going to get, a good approximation of the distance. But if you use the control that made the map, then you are superior to the map because you're using the control of the map. Just like the Royal Engineers.
The scale map, Larry. Everybody knows that. You can use the scale map to determine the distances already. That's what you're doing, right?
Unless you want a higher precision, then you have to go to the control that made the map.
But you're only going to one point and you are measuring an angle. That's all you're doing, Larry.
Yeah, that's all I'm doing.
I mean, you do know about trigonometry and that. Like, you can't do fuck all with an angle. With one angle, you've got nothing.
That's why. How many red lines are on that map? Not one, many. There you go.
That's angles. They're all individual angles taken. and then you've plotted yourself on a map.
Yeah, that's what I did. You're right. You're right. Yeah, you're right. The smoke and mirrors of geodesy for the past couple of centuries, yeah, all fabricated. You figured it out. You've spotted the problems. Why don't you call the Royal Engineers and tell them Ordnance Survey Maps UK are all bollocks?
No, Larry, we're just saying about the water level, Larry. That's all. Oh, it's just about the water level. We're on about Slice Barcanes, 100 metres. And then we established that the Reciprocal, I don't know, you didn't know much about that. Didn't realise that it needed 2.
Your signal was a little bit dodgy there.
Yeah, I've got to keep moving now in the car. So, do you want to go back to that Reciprocal? What he was doing? I don't know.
Yeah. Rakia's here. What's up, Rakia? Are you busy?
Yeah, I'm pretty busy, but I'm listening in.
Yeah, that's cool. Yeah, man, that's great. You came by, Larry. We'd like to talk to you. You know, quite a bit. Bev's on the road, so it's a little bit difficult right now. But yeah, from what I've studied, and I'm not a professional like you, is that reciprocal leveling techniques are not accurate. And the only way to determine a elevation, like George Washington, right? So all the surveyors, Abraham Lincoln was very accurate, right? In determining, quality maps, elevation. They were concerned with, level. I think we lost him. I think we lost him right there.
Larry?
Mm-hmm.
Oh, is he gone?
Did he leave
Yeah.
without saying bye?
He may have dropped out. Maybe he'll come back.
Yeah. Yeah, I wanted to have a word with him about our water level test, the straight line test.
Mm-hmm.
Got into that. But yeah, I was good of him coming round.
Yeah, great. That was, I don't know how long that was. Maybe an hour? Not really.
I wanted to know if he had gone back to his building.
Yeah, I wanted to get there. There's loads of questions about Larry.
Well, he's
Crap,
supposed
he may
to,
have.
when it warms up, he was supposed to go back and shoot it again. And I want him to go in the middle and shoot either way,
He may have left because he could sense that was coming. I don't know.
Yeah, I don't know. I hate to put that in him, but he usually doesn't leave. But usually people say, bye when they're leaving. So maybe he just dropped out. Maybe he's not being, a jerk.
No, he's
just
fine.
got disconnected.
Nah.
Yeah.
He just got disconnected.
Yeah. No, I
Cool.
think he'll have lost his signal or something. The power will have gone around at his house. He wouldn't have just dropped out like that.
Well, there's a lot of satellites going down right now. They're getting of age, so we don't have the signal strength that we're used to right now. I think they're updating the system.
Oh
Yeah.
shit!
think-
one just
think
fell
they're
across the
moving-
road.
I think they're moving to more of a local tower base, putting a lot more towers up so they don't have to worry about the maintenance and the downtime of all the, sky stuff.
Yeah.
Let's hope anyway. That seems like a more logical way of doing things.
Yeah, I went live as soon as I could. I was like, shit. I went upstairs and went live.
I was stalling. I was stalling
Yeah.
as long as I could. It's like, oh, shit.
You're like, we're on?
Oh.
We're on? I was like, yeah, we're on. That 1 mile drop, the 8-inch drop.
Yeah, we got elevation change. We got it all there, I think.
Yeah.
Well, Larry got 2 inches of drop over 1,500 foot, if I'm right on the numbers. That's pretty amazing right there. That's easily measured, right? So you could mark that drop on that building or wherever else. I mean, obviously, if it's on Earth curve is on that building, it would be 1,500 foot. There would be 2 inches of drop everywhere, right?
Yeah.
So that would be easily measured. That's what I want to replicate.
Definitely measurable. Like everyone says, or everyone that pretends to be a surveyor says it's definitely measurable. Larry said it. But
Did you hear his answer?
Is an elevation change.
Right.
Well, did you hear his answer? My God.
There for a while they were saying it wasn't measurable, and now we're moving into the realm that it is measurable. So that's a good thing, right? I mean, because these tools aren't that expensive or hard to use, and the measurements are short distance, really easy to do. Yeah. And you can be anywhere, right? I mean, literally, you can be anywhere on this land that we live on and measure that, because everywhere on a sphere would have to be basically doing the same thing.
Yeah.
I don't know if my signal was clear enough when I was talking to him, but I'm not sure. It seemed like he wasn't really sure about the difference between differential and reciprocal.
When you dropped out, I had a word with him about reciprocal and said, you're looking at that tower. Yep. Reciprocal. Yep. He's like, well, where's your other one? Like, what other one? It's like, you can't go up there, can you? No. He went, no, exactly. And he's like, well, how can that be reciprocal? You do actually understand what reciprocal is, right? And he didn't. He hasn't got a clue. So what sort of a surveyor wouldn't know what reciprocal meant when you were talking reciprocal leveling? It means from both sides at the same time. Measurements taken from each side. That's what reciprocal means.
And at the same time is the other key.
Yeah, well, as close as at the same time as possible,
it's close and because things change, right? That's the reason they do that, because they know that the environment and the situation changes, the atmosphere changes. So that's why it's in close proximity of the same time. I mean, you want to do it as quickly as possible. Or have two surveyors doing the same thing at the same time.
Yeah, he said that he could look down that mile with a theodolite. And I said, what are the limitations of reciprocal leveling? He said, about 300 meters. I said, why are you looking a mile then? What do you call that technique?
No, he's right, though, Clear. He's not wrong when he says he can look down a mile.
Yeah,
he can look.
Just you can't do anything accurately.
Yeah, my mistake. He can look.
Yeah, well,
now that I've started
you want to
paying
find
attention,
drops. That's the instrument you want to use.
Well, now that I've started paying attention, I've never seen or talked to or been around a surveyor that uses his tools over a mile like that. I mean, well, not an auto level.
Yeah. And not vertical angle measurement. I mean, next time you see the surveyors out there with the theodolite, right, and ask them, what's the furthest distance they've ever measured a vertical angle change? And also, what's the smallest angle they've ever measured vertically with the theodolite? Because I think you'll be shocked by the answer.
Yeah, I want to go and look at a distant antenna on a known elevation mountain peak and try to determine what I already know about the height of the antenna.
Yeah. Use everything I know and then match the angle. The other thing that I've found funny when talking to these surveyors on that are actually working out in the field, when they're talking about using these theodolites and setting up the GPS system, they're using satellites, basically, is what they're calling them, but it's actually specific points around the area on tall structures such as water towers or buildings. Usually their main hub has a tower on top of it, and that's one of what they call satellites, right? And I think people get that mixed up with what a satellite, they think they're satellites in outer space, and it's not. It's just a satellite on top of a building. They're just calling them satellites.
Yeah, it's central. It's the central highest position, isn't it?
Yeah, there's tons of them. I think they're on all these cell towers now. But you look at any tall building or anything like that, and go look at any main surveying hub for the city or whatever. They have their own system that has a benchmark on top of their building, basically, and they're sending out signals from there. They know the known height of that, and they're taking elevations based on that known height. They're sending out signals, local signals, to towers that surround them, and it's connecting to 4 or 5 of them locally, and they're getting their coordinates and elevation. I think that's why the elevation has gotten more accurate.
Rocky, when are we going to go through your $100 video? You have that, right?
My what?
Your $100 video that you got from Jose?
I paid for it. I think we need to use it. I mean, I've gotten plenty of use out of it. I should have paid George for his pictures of the water appearing above the horizontal, because that was one of my claims they laughed at me about for a year, but I didn't have to pay for that one. Thanks, George. But Larry's building, that's exciting stuff to me, because that's something I can go out and measure. That's something that my neighbor, if he chooses to, can go out and measure, right? Obviously, if that building is following the curvature of the earth, then every engineer, right, would be following the same, parameters, and every building you can measure that's that length. You could measure the curvature of the earth. And or you could get further. If it's 1,000-foot building, you could get 1,000 foot away from it and shoot each corner and see that it's curving away from it. I mean, it has to, right? If it's level.
Yeah.
So that's exciting stuff to me. That's why I've been waiting on George. I haven't really pressured him lately, because he said he was going to do it. I take him as a man of his word. I mean, he's a professional surveyor. Has to have the integrity, and when he says he's going to do it, I'm just waiting now. It's just a waiting game. Should
we concentrate on that sort of stuff then? Because with this GoFundMe and the force the line sort of thing, and Slice Barkane's bending water level, and Larry's sort of being able to measure it, I mean, surely these are the people that should be coming together to sort of help each other, shouldn't they?
Well, they hold our feet to the fire, so I think we should hold their feet to the fire just as much. And like I said, they're the authority, right? He's the professional surveyor. He should be holding himself accountable and doing these things, and then we could replicate what he's doing. And if we do something wrong, he could teach us what we did wrong. I mean, that's fine with me. But having a test that we can go out and replicate very easily. I mean, I have the tool to do that today. Right now, I could go to a building, and if he told me, I needed to be this far away and I'm gonna get this many inches in elevation change, which is earth curve, hey, I'm fine with that. I'm gonna go do it.
Well, I've got an auto level and a canal, so I mean, I'm in a position to be able to do that sort of stuff as well. So I mean, I'm all up for it. If Larry wants to, when he gets his power back, we'd love to have a chat about how we can progress this. But we'll go over
he'll get a better connection.
Yeah, it seemed like when I brought up the hydrostatic equilibrium, establishing a horizontal dead straight line, it just kind of went quiet there for a second. I'm not sure if he dropped out, but it got real quiet.
He might not know about that. I mean, to be honest, I didn't know about that 6 months ago. The other reason I hold this dear to my heart here is I do this for a living, right? If I'm doing it wrong all this time, right? If I'm not making something level by following the earth curvature, I need to know. Yeah. Because no engineer has ever told me if, I'm scared that I might get a project that's a mile long and I'm going to be 8 inches off if I don't follow the earth curve. I really don't know. I'm kind of confused on that point. Either I've been doing it wrong this whole time, or or it's just not happening.
Yeah, that's a good idea. We'll have to go over that, because we've also got what's his face, Fe Dogma. He came round and did surveying thing for us as well to sort of show us how level is actually horizontal. Remember that? We could go
Yeah.
over that too.
There's more surveyors out here than I ever knew, right? I mean, everybody seems to be a surveyor now.
Yeah.
That's amazing. This could easily be done. So with all the surveyors around in different parts of the country, surely someone can make a video besides Larry. He's the only one that I've seen in all these years that have made a video of Earth curve. And he did it alongside of a building. So it's not something that's hard to do. I think all these surveyors should go out there and make videos like that. I challenged B-Ball last night. We really don't need anything else from anyone except for videos on how to measure Earth curve. I think that's where we're at right now.
Yeah.
How do you do that?
I've been asking for it for ages. What's the method?
Yeah, I think spot on now. But he said if you want to see optical drop, that's what you do. You look a mile down the road. Just optical though, right?
Yeah, horizontal drop. Yeah, not measured, just shown, right, optically. You just look and you see it. You don't measure it. I mean, because if you try and measure it, things get all kind of out of whack and you don't know which refraction to apply, blah, blah, blah. But you can definitely see it. Well, I think it's time to measure it.
Yeah, well, that's what we're about here, isn't it? Practical. Right line geometry. Let's get this done. Prove it in the real world.
Yeah, I've been asking Larry to come in here for about a year, and all of a sudden he just dropped in. I was like, "Hey, Larry."
Hey, how you doing? Yeah, I'm sorry I wasn't listening because I could have been.
Oh, it's recorded.
And I just thought, I'll go back and listen to it because Larry usually has some good stuff. But also, the people that I did my tests with, we thought, with all of our experience, that we were creating a horizontal, and I've learned on the internet that I wasn't. I was actually forming a curve, which is so-called level line over the path of the water. That's not what I was doing, and I don't think anyone on the group was doing the same, think that. I don't think anybody even thought of that. We were just creating a horizontal above the water, and then we measured down to the water, and some of us were surprised that there was no drop and some of us weren't.
Yeah, well, you didn't realize that the curvature rate of air is altitude dependent, apparently.
Did you realize that none of you had the conception that straight line was curved when you were doing it?
Yeah, the segments that we were doing, differential leveling and double back, we were doubling back and closing the loop and we actually used 3 different types of horizontal tools. I wish I would have used a water level, but in my mind, I actually did, right? I used the water level of the lake, but I actually didn't measure up to get my grade, my benchmarks. I used the water to see if there was any drop, and there wasn't. But, obviously I did it wrong. A lot of people on here have told me, Blue Marble, Larry, Jesse, Soundly, everyone told me that I did it wrong. And but no one's really shown me how to do it better. I've never seen any video of them setting out benchmarks over static water and saying, look, from the top of this grade stake down to the water is a foot, and a mile down the road it's a foot, 8 or whatever they say it would be. I've never seen that. Never seen that video.
Yeah, you don't.
I'm open to all do it.
You don't know what a map is? You gotta say a map. But he put in this thing here, Gary Wabinga's instrument. A tube on a carpenter's level looking through a car windshield. What the heck?
Perhaps he's after your grand. That's the first one, looking through a tube to see the light.
Yeah, maybe so.
We have a company, construction company here that's MAPP, and they pronounce it MAP. And I guess I don't know if he was referring to them. I don't know what he was referring to. What a map is.
Had a real
emphasizing at the end, wasn't he? Like that.
Yeah, map. I kept hearing that, and Rocky had typed it in there. Map.
Well, I didn't know if it was a special term, like, you know, these professionals sometimes make up their own lingo.
Yeah.
Never heard of that.
I've been on
Code word.
Twitter for a long time, and if you go on Twitter and look for the hashtag all maps are flat, you'll find quite a lot of my tweets there.
I
Because
bet.
anytime they talk about a map, so he may be referring to that, possibly. Because they don't like the idea of that. That's one of my challenges. I've always said, show me a curved map. Just one. I just want to see one curved map somewhere. Not a globe. A globe is a model. That's not a map. A 2-scale curved map, please. Never been shown it.
Yeah, Larry's showing us his wild theodolite. Looks like Doofus is what do you call it? The Wild Boys?
Oh yeah.
Mm-hmm.
You might have lent it him. That is the one that Jesse gave him, I think.
Yeah.
And then he gave it to Jeff, I think.
Mm-hmm.
But it looks like he's got it back. Or just to add a load of pictures from when he did have it.
Yeah, I thought Doofus was Jeff, but then the other day in the Doofus account it was Cosmo, I think, talking.
Yeah.
They must share the account.
Yeah, I think they were close. Long time.
Well, that was a very good discussion there. Hopefully I'll come back again.
Yeah, I want that recording. I want that for myself.
Oh yeah.
That's got to go in the surveyor's discussions. But like I say, we'll talk to anybody that thinks they've been a surveyor or imagines that they want to be a surveyor, thinks to pretend that they want to be a surveyor, or even but like real surveyors. That'd be even better. But I'll talk to anyone about all of that stuff, because this is just like Rakia says, this is practical stuff, and these are the people that do actually measure it. So they know, or they should know, about how to perform their profession. So I don't know.
I heard Larry sort of smirk a couple of times. Points,
Mhm.
you know, were placed at him, and it was just that, you know, that yeah.
The nervous laughter. Yep.
Not knowing what reciprocal is, though, is a bit of a. If you're claiming not to use differential leveling and want to use reciprocal, then I don't know. I don't really know what it's on about.
Yeah, he said it could be both, right? Differential can be reciprocal, and reciprocal can be differential. And I was like, whoa, easy.
Well,
what are you saying?
at the turning point to go back again, could you call that reciprocal if you're going back? But I mean, you wouldn't really want to close your loop by going back over the exact point. But I guess you could if you wanted to.
Mm-hmm.
But I don't know why he just doesn't understand what reciprocal is. So
Yeah, maybe he just forgot.
reading it up. Yeah, maybe it's been a while.
Mm-hmm.
I enjoyed listening then anyway, so thanks Larry and all involved in the conversation on that.
Yeah, I was quite impressed. It was a surprise.
Yeah, certainly.
Right, I'm back home now anyway, so I'll be swapping back onto me.
Definitely getting a lot of traffic through here now. Getting some pretty interesting discussions going on. Wonder what brought Larry in here. Hey, there's Larry. clapping. If you're listening out there, Larry, on YouTube, you're welcome back anytime.